So today, what I want to talk to you about is what I call real-time big data. With a new library that we just released in the 1.0 version, I'll tell you a little bit more about what that means, called .NET for Apache Spark. And I'm going to show you a feature of the Azure cloud called Azure Synapse Notebooks that ties in quite nicely with this. For those of you who may not be familiar with big data or Apache Spark, which I certainly was not when I first joined the team, I'd like to give you a little bit of background around what that is. So what is Apache Spark? This is a unified open source parallel data processing framework. That's a big description, but what does that actually mean if we drill down into the details? Well, what the system does is it brings together things like batch processing of large amounts of data, interactive SQL, real-time processing, machine learning, and deep learning. It also provides graph processing services. This is a conceptual diagram of what Spark looks like. It sits on top of some sort of what we call resource or cluster manager. This might be Kubernetes, it might be some other distributed system. There are several flavors or platforms that run Spark, if you will, but everything supports what's called the Spark core engine. That is the main engine that does all of these distributed capabilities. And then on top of that engine are plugins that plug in to do Spark SQL, to run machine learning, to do streaming, and to do GraphX. .NET provides a full spectrum of support, and it does it without modifying that core Spark engine. And that's really important because we're not just changing the engine and trying to keep pace with updates. We're an add-on to that existing engine, so we're able to continue to provide value as Spark iterates. Currently, we support Spark versions 2.3, 2.4, and 3.0, as well as several functions, and I'll show you what a function looks like in a minute. We target .NET Standard 2.0. That means it's cross-platform, whether you're on a Windows, a Linux distribution, or a Mac OS, you're able to use .NET for Apache Spark, and that includes C# and F# support. And it includes all the support you need for batch and streaming. So whether it's an offline workload that runs in the background or if it's a continuously updated workload, those are all supported. What does it look like to program with .NET for Spark? The first thing that you do is you create what's called a Spark session. That's a context that contains all of the data and information and APIs you need to work with. So this is a simple call to create a session, and it's basically saying get a session if I've already created one, or create a new one. The main thing that you work with in Spark is something called a data frame. I like to think of a data frame as a table, almost, if you're familiar with SQL or databases, but it's a lot more than that, and I'm going to oversimplify it. But .NET developers who are familiar with LINQ are probably familiar with the fact that you can build a query in LINQ, so you can put in a filter and an order by, and that's just a template that just describes what you're interested in doing. Nothing really happens until you cast it to a list or start to iterate over that LINQ query. A data frame is very similar. A data frame sets up a context of data, allows you to specify manipulations, and then you can inspect and iterate over those. And we're going to show you all of this live and in person. Another great thing that you can do with .NET for Spark is create what's called a user-defined function. So if you have some sort of computation, you can define that computation, hand it off to the Spark engine, and run it as part of your queries. That means that if you have existing libraries that you've built algorithms and processes into, you can reuse those as well. This is an example of manipulating and viewing data. It uses a filter to pick people with an age over 21. Then it uses that user-defined function to create a column. It's basically just selecting one column that concatenates the age and the name, because that's what that function does. If you're familiar with something called Scala or Scala, I'm not sure the proper pronunciation, but this is a language that comes out of the box with Apache Spark. So there are a lot of examples out there. On the left side is an example from a benchmark. It's basically a set of tests that people use to ensure that an implementation of Spark does all the things it needs to do, implements all the features. On the left side is Scala. On the right side is C#. And the first thing you might notice is it's very copy-paste friendly. There are differences, but the differences are small enough that you should be able to take existing code examples. And the team was very focused on making sure there was as close of a connection between the existing code base and new code that we create with .NET, so that you could look at existing examples, and even if they weren't converted to C#, for example, you can still copy them over and with a few tweaks get them running like we did on the right side. There's a few conventions that are different. For example, a $sign represents a column on the left. The function COL represents a column on the right. And there's some capitalization differences, but for the most part, they're very similar. If you've worked with Spark before, you've probably submitted a Spark job. In a typical Spark application, you would build the application and put it in the equivalent of a DLL or a package called a jar file. Then you would submit to Spark that job. So you're basically submitting it. You're telling it which class contains the entry-level code that you're going to run. You give it the path to that container, and you pass it any parameters. If we look at the .NET side, we provide a shim or a class that makes that interface between .NET and Spark. So these are provided by .NET for Apache Spark. We have a specific class and a specific jar file that contains our implementation. As a parameter, you then pass your .NET app. And don't worry, I'll show you what a .NET application looks like. It's a lot simpler and more straightforward than it may sound up front. Before I dive into an example, I do want to share what developers are saying. A question I often get is, why did we even bother building a .NET for Spark? And there was a need within Microsoft to use some existing .NET libraries and apply them to Spark. So this was born out of a specific need. But we wanted to take this out to the public. It's an open source project, and we want people to take advantage of it. So we reached out to developers, and we received over 200 responses, the majority of who consider themselves developers or architects. And we asked them some questions around Spark. For example, we asked them, what language do you like to use when you're building your applications? And as no surprise, the languages that have been around the longest for using with Spark, like Python, Scala, and Spark SQL, came up first. But it was nice to see that 1 in 3 respondents, or 30%, are using C#. We even had some people respond who are using F# for their .NET for Spark jobs. We also asked, what platform do you run on? What does your development environment look like? And we found that twice as many developers use Visual Studio as compared to Visual Studio Code, which was interesting. And we also found that 70%, or about 3/4, run on .NET Core, and which is why the team is committed to supporting .NET Core moving forward. Now, we asked about scenarios. What do you use big data and .NET for Spark for? And what was interesting about this is we asked it for big data projects in general, and then we asked it specifically for .NET for Spark projects. And what we found is they were very similar. The most common scenarios are extract, transform, load data, ETL, or basically data transformation, analytics, mining information about data, and data warehouse, storing large amount of data to feed into other processes. The challenges were the same whether someone was on a different big data project or on .NET for Spark, And those challenges were dependencies and setup and documentation. And what was nice for the team when we did this survey was we found that we were already addressing both of these items. We've done a complete rewrite and update to most of our documentation. We found areas that were complicated or didn't cover things and added to those. But we also have a solution for dependencies and setup that I'm excited to show you. The most requested features were being able to submit those jobs. I showed you how on the command line you can submit a .NET for Spark job. Everyone wants that experience where they build it inside of Visual Studio and can submit it just directly from Visual Studio. They're good DevOps professionals, so they want to integrate with their continuous integration and deployment pipelines, and they want to integrate with machine learning.NET. What's interesting is because .NET for Spark is at the end of the day .NET, it already allows you to pull in the ML.NET library and do things with it. But developers want a tighter integration to be able to hand off data sets between the two engines. So that's something we'll look at. But let's take a look at a simple demo for getting started using some tools that the community provided to make it easier to create an environment. And as some background for this demo, ordinarily, if you were going to run a Spark job locally on your laptop like I'm going to do, you would need to install the Java SDK because Spark does use Java. You need to install a Spark distribution, something like Hadoop in the back end, and you need to configure and set up environment variables. There are just a few steps that you go through, and they're fairly straightforward. We have those on our website, but they are dependencies and other installations. Fortunately, the community built a Docker container that contains all those dependencies for those. I do not have the Spark distribution on my laptop because I either use it in the cloud or I use this handy container. Let me pop over to Visual Studio Code and show you an example. Now, this is the entire application. You can see I just have a project file and I have this program.cs. This is a .NET 5 application, and I just did .NET New Console. So I'm creating a console app, and I'm using what's called a top-level program. That allows me to write a program without having to create a program class or a static main, etc. I added one package. If we look in the project file, you can see that we included Microsoft Spark. And I'm putting some using statements. I'm starting the session. Remember, I said you start with a builder, get or create. And then I'm reading a file. This is how the API reads a text file. And I'm going to show you a variation of this read because there's different file formats you can use. The goal of this, I created a text file for .NET Conf that just has some of the language off the website. As you know, we just released .NET 5. So this text file contains that text and we want to count the words. So this is using some code. I'm not going to spend too much time here because we're going to do a deeper dive when we go into the notebooks, but I've set a breakpoint. And if I go ahead and hit F5 right now, what is probably going to happen is we're going to see a big red error because I have no connection can be made. That's what this says down here, because I didn't install Spark on my machine. But I pulled this community image. So what I'm going to do is just right click on this image. This is a extension in Visual Studio Code that lets me work with Docker. I'm going to tell it to just go ahead and run that image. So up here in containers, what we'll see is there's now a container that's up and running. So there's one more thing I'm going to do before I jump into the application. And that is, because this job is going to run inside of a container, I need to give it that file. So what I'm going to do is I'm going to look at my running containers and notice that this container has a unique ID. I'm just going to copy. That's what the cp command does. This .NET conf.txt file, And the container I'm going to copy it to, I just need enough characters to uniquely identify the container. So D241 is enough. And then I tell it the path that I'm going to copy it to. And that should drop that text file inside our container. So let's go ahead and come back into our code. We've got our breakpoint set. I'm going to hit F5. And we'll give it a second, and you can see it hit the breakpoint. So it was able to start that Spark session. I'm going to step over this. That just defined the action that we want to do. When I call show, it's going to actually process and output something to my terminal. And there you can see we got the word count, and not surprisingly, .NET is the most popular word that was counted. So let me stop this. I'm going to go ahead and clean up my container. We'll stop that. And I'll close out code because I don't need that anymore. But that's a simple example of getting started, a very quick inner development loop. I created a console app, started a container, and I was able to debug and start working right away. With a notebook experience, you can go even faster and more real time, and that's what we're going to dive into. I mentioned our 1.0 release. That was just released a few weeks ago, and this has a ton of community contributions, a ton of issues addressed, and a ton of APIs that it supports. So it's a very full-featured release, and we're very excited not only to use this release in production, but also to start to build on the next version of .NET for Spark. The great thing, again, about this tool is it really works everywhere. It's cross-platform, as I mentioned, thanks to .NET Core and .NET 5 that run on multiple platforms for us, but it is also cross-cloud. We would love for people to use the Azure experience and to run it on Azure, but it will run on AWS, and it will run on other services that support Spark. And that's the spirit of an open project that can be taken anywhere and run anywhere. Now I want to talk about Azure Synapse Analytics. This is a service that I believe goes quite nicely hand in hand with .NET for Spark. I call it the Big Data Control Panel. That's my words. It's not official language. But it really is a one-stop location to work with large amounts of data. It basically provides a way for you to connect to different data sources and pull that data in. It gives you the opportunity to compute, and that's defining jobs that you submit, as well as use notebooks, which is the experience I'm going to show you. Conduct orchestration, so you may have pipelines that have multiple steps and just data from different sources, run different pieces of code across them. You can monitor what's happening, and you can manage your pools and services and security, all from a single spot. So I've shown you quite a few slides. The rest of this is going to be pure code and pure big data fun. First thing I'm going to do is jump over to this tab, and this is what's called a Synapse Workspace. This is where all of the effort begins with .NET for Spark in the Synapse Workspace. Down this left-hand side, you can see I have multiple options. This first one is data, and this is what connects me with the different data sources that I want to work with. You can see here I've got a database for Spark that's up and running, so this will allow me to insert tables and query information, but I also have this linked tab, and the linked tab allows me to specify connection strings and integration data sets that come from other sources. For example, I've connected to Azure Cosmos DB so I can query and mine the data that's in a Cosmos DB database. I've also connected to Data Lake Storage. I have a couple different workspaces here, and we're going to deal primarily with this workspace. I'm going to come back to that in a second. And you can add and manipulate as you like. I'm going to spend most of my time here in the Compute tab. And you can see that there's two pieces to this compute tab. There's notebooks and there's Spark job definitions. The notebooks are where I interact and work with data in real time. The job definitions are where I take code like the code that I showed you earlier and I submit it as a job. And there's a way I can upload it to file storage, point to it from this job definition, and cause it to run. In fact, I think I have a job here. You can see it's basically pointing to a zip file that I updated, passing some command line arguments, specifying the entry point, etc. These are my pipelines. Let me close this one out and open pipelines. So pipelines are ongoing processes and orchestrations. So I may have a pipeline that says on a frequent basis, take this data here, manipulate it, and place it over here, or connect to data sources, etc. And this is where I will orchestrate. This is where I monitor. And you can see I can look at SQL requests as they come in, data flow, and Apache Spark applications. And you can see here I've got one that's in progress. I spun up a notebook before I did this so that we can interact with some data. We'll come back to that. And then finally I have my management, which is where I handle access control, credentials, and something called pools, which are groups of resources that we can use. Now, if this seems to be a lot of information, one nice feature in this portal is if I come up here to the question mark for help, there's a guided tour that'll step you through the different processes. There's documentation, Q&A. More importantly, there's this knowledge center. And in the knowledge center, there's a gallery of samples that show you data sources. So you have ready-made, out-of-the-box data sources that you can connect to. And as you can see, there's some COVID data, etc. We also have SQL scripts that are showing you how to do different queries. We have existing pipelines. You can see here are some of the things you might do in a pipeline: copy from Google BigQuery to Azure Data Lake, HDFS to Azure Data Lake Store, etc. So there's tons of different scenarios. And then finally, we have existing notebooks. I'm going to go ahead and filter. I'm going to go to this language, and I'm going to filter to just Spark.NET C#. And you can see there's an example here, user-defined functions with complex types. If I click on this and say continue, this is actually showing me the notebook here with all these steps. Now this is something that I can read. It's a preview of this. But if I click open notebook, it'll create a notebook, insert this code into it, and I can start interacting with the data. Instead of doing that though, let's do something fresh. So the first thing I'm going to do for the example I want to show you, so I'm going to come here into the data tab. I'm going to open up this Synapse Workspace, go into my file system, and I'm going to upload a file. So let's go ahead and create a new folder, and we'll call this Dev Day. So that's a folder to hold some information. Going to go into this folder, then I'm going to upload a file. And for the file, I'm going to go into my app data. I happen to have run a process earlier that created a CSV file. And that's going to be down here, Spark ML dot categorization, session 1, Spark dots input. So let me go ahead and upload that. And while it's uploading, I want to show you that CSV file. So this is Spark.input. What I did was all of our documentation is open source, and each project has a different documentation project associated with it. So I pulled down the ASP.NET Core documentation and ran a simple program that pulled off the file names, which are in this column, extracted the titles, and then pulled the text out of the markdown. So it doesn't have any formatting, links, images. It's just the pure words. Each row in this spreadsheet, if you will, this comma separated file, is a file, a set of titles, and some words. So that's what we just uploaded into our file system. So let me come back here, and what I'm going to do is highlight this item, and then under more, I'm going to go into properties, and I'm just going to copy the path to the file. There's a special file format now that it's in cloud storage. Now here's my notebook. My notebook, it's a dev day notebook. What I've done is I've started a session. That's this builder, getter, create. And then I put a placeholder for another step to actually load the file. What I'm going to do is paste that path I just grabbed. And what this is doing is it's using the read API. It's saying that there's a header. So we have a header row in our CSV file. And instead of using text, which is what I used for the counting words example, we're telling it it's an actual comma separated file so it knows how to parse it out. And then we're telling it, let's show that data frame. This last line here, create or replace temp view, right now this data frame is just a variable in my notebook. By using this extension method, create or replace view, it will store this information in a table that I can query in SQL, and we'll see what that looks like in a minute. But let's go ahead and run this and let it pick up that file and pull it out. And it looks like we may, I had hoped my session was still running, but it may have stopped. So sometimes it takes a while to spin up. But while it's doing that, notice that I have this attached to Spark Pool. So this is where I have different options of different sizes. I can pick my language, but the nice thing about these notebooks is that you can use multiple languages. You can mix and match, and I'm going to show an example of what that looks like with something called a magic command. So let's, and you know this trick probably, so this is going clockwise, so if we rotate the cursor, this should speed up our session. And let me just show you one more thing. We'll let that run for a second. I'll pop out here. Let's cancel out of this one. Go into notebooks. And actually, there we go. Spark is up and running, so it should just be a few more seconds for it to process and parse it out. And there we go. So now it's pulled it in. So it basically spun up the system because I hadn't used it in a while. And instead of continuously billing me for the service, it said, okay, let's idle down. So it spun back up. And now we can see just a sample. When you use this show command, it just shows a few rows. It doesn't show the entire file, only showing top 20 rows. Okay, so let's go ahead and move on. And what I'm going to do is take this little plus, and I can do a markdown cell. So if I'm doing this notebook to share with other people, I might want to insert instructions into the notebook and tell you this, that, or the other. I'm just going to jump into another code cell. So let me click on this, and that opens up a new cell for me to type in some extra text. Now I'm going to go ahead and copy paste so you don't have to see me typing too much. But the first thing that's interesting to us is how many documents did we actually pull into the system? And I see my video got a little quirky here. Let me just
Hi, Jeremy. Sorry to interrupt you. We don't hear your sound. Is there any problem with your devices?
Okay, this audio is probably not going to be as clear, but can you hear me on this?
Yes, I can hear you well. You can continue. Sorry for interrupting you.
Okay, yeah, not a problem. It looks like I lost video and audio at the same time, so I'm switching to my backup devices. Basically, what I was showing there was getting a count of documents. We have 646 documents, which is interesting. But let's do some manipulation of these documents now. And again, I'm going to go ahead and paste something in to save watching me fumble with the keyboard, but I'll explain to you what this is about to do. So this piece of code is selecting from the docs that I just uploaded, and then it's pulling out the column file. So it's saying keep that file column as is, but the words column that has all that data from the article or page, if you will, it's telling it to split it into a word list. What split does is it'll split it on the space and turn it into an array. So instead of one column, with all of the words, we get an array with multiple words. Then I select what came out of that. So I've got a file and an array, and I tell it to explode the array into a column per item. So now we've flattened this out, and we have something that looks like this. If I go ahead and run it, now you can see for this file, it's pulled out every single word in the file. So now I have something interesting to work with. Now that I have the words pulled out, I'm going to pull up something called term frequency. Term frequency is just a count of how many times the word appears in that single file. And once again, I'm going to use, notice that I have this words here. So I had docs, that was the original data frame where I loaded the data. Now I have a second data frame called words, and that's the words expanded out. So if we continue, what I'm doing is now I'm using the group by command, and I'm telling it to group by file and word and give me a count. So that's basically giving me the count of that word by file. So let's go ahead and run this. And notice how easy it is for me to just build on previous steps. I can take the steps, and now I can see this file has the word the 268 times. It has the word to 81 times. So I'm starting to get some interesting information from the document. So it's interesting to figure out how many words are in each file, but it's also probably important to get a word count by file. So we can see which documents are bigger, which ones are smaller, etc. So the way we would do that is we're going to create another data frame called rollup. This is taking the term frequency, so it's taking this previous data frame, grouping it by the file, getting a count, and then selecting the file count. So it's basically giving me that true word count by document. So if I run this, what I'm going to see, and oh, it says I canceled it. So I was double-clicked the cell. That's the other thing, is you can click on the cell to cancel a job if you feel like you've written a query that's going to take too long or if there's an issue. So now we've got word counts per document. So we've already taken that information, we've exploded out the words, we figured out word count by file, we figured out word count by document. It'll continue to get more interesting though, because we're going to do some more interesting things. The next one is what I call document frequency. And let me actually cancel out because I just typed over close and discard changes. I just wiped out my query trying to copy it for you, but we're coming back into it. Okay, so we'll do this. All right, so now I'm going to get what's called the document frequency, and I'll explain why in a second. This is the frequency of the words across all of the documents. So in other words, if I have the word the, or if I have the word Azure, for example, instead of counting it in a specific document, I want to see how often it appears across all of the documents in that repository. So what I'm doing is I'm going back to my original words data frame. That was one we defined earlier, grouping it by word this time instead of file, just by word, and getting that count and calling that document frequency. So let's run that. And here we can see like the word the appears 70,000 times across everything. And this is a segue into what I'm going to do next. I have a project that's on a GitHub repo that analyzes these documents and uses machine learning to automatically categorize them together. And to do that, it has to understand what the important words for the document are. If we just counted how many times a word appears in a document, we would be thrown off because the word the, or the word to, or the word a for these language documents would always win. So there's a formula called inverse document frequency. And what that formula says is basically what makes a word important is if it doesn't appear that often across all documents, but it appears a lot in a specific document. So in other words, if I have a word called wizard that only appears in one document, the count across documents is probably not high, but it's probably high within that one document, and that makes it more important. So the first step is something called the inverse document frequency. This is a number that gets higher the less the word appears within the documents. And there's a formula involved, so I'm just going to show you the formula, but I want to show you how easy it is because I'm using C# and .NET to make this work. So I'm going to add another code cell, and I'm going to paste this code. So what I've pasted is just a simple method that takes the document frequency and the total documents and does this logarithm to compute the inverse document frequency. Then I'm registering it as a user-defined function. So this says I'm going to take two ints and return a double. The name of this is calculateIDF, and the method it's using is the method I just defined there. So if I run this, all this is doing is just parsing that method out and making it available as a user-defined function. Now let's actually use that user-defined function. So I'm going to come down here, add another code cell, paste this in. So now what I'm doing is I'm going back to my document frequency, how often the word appears across all documents. I'm adding a new column, that's what this .with column does, called total. And the total is going to be the same on every line. It's just the total number of documents, which is 646. We computed that earlier. Then I'm creating a column called inverse doc frequency. I'm calling the user-defined function with the doc frequency column and the total as an input. And then this last little bit is interesting because I found that some of the words that got parsed out were just numbers or had underscores, and those are less likely to be interesting words. Those are probably snippets of code. So what I'm doing is using a regular expression to turn it into only the alpha characters. And then I'm matching it to itself. So if the word with only alpha matches the original word, we keep it. If it's different because there were numbers or underscores in it, we throw it out, and then we order by. So a lot going on in this little function, but if I run this, what we're going to see, give it a second here, is we're going to see more interesting words. So a lot of these words have the exact same inverse doc frequency because they only appear once across the entire set of documents. But it's things like untrustworthy, insulated, surprised. So these are much better words than to or a or of or simple things like that. So now let's use a magic string and start to add some mix and match. And what I'm going to do now is I'm going to jump into some Spark SQL. So this first one, if you've worked with a SQL database at all, should be pretty easy to recognize. I want to create a temp table to do some work in. So I'm using my magic string. That's what this %% SQL does. It says now I'm going to use Spark SQL. And then I'm just simply saying if the table IDF join exists, drop it. So that's pretty straightforward, and that just lets me rerun this workbook multiple times, and I just recreate the table each time. While that's spinning up, I can come down here, so it's already run that. Now I'm going to load some data into the table. This is a ordinary looking SQL join. So you see we have a selection, but notice I'm using those data frames that I defined in code. They're now available to me as SQL as if I'm just querying tables in the database. And I'm grabbing some information, computing this multiplication. So what I'm doing is taking that inverse doc frequency, which is the importance of the word, multiplying it by the word count, and using that to figure out which words are important by document. So let's go ahead and run that. And then the last thing I'm going to do is just show you what the results of that looked like. So I'm going to add, what did we see here? Table review. Did I forget? I dropped it and then I didn't create it. That's probably a important step, right? So let's go ahead and do this. Let's insert a new step right here. And let's create that table that we just dropped. Should be pretty quick. And then let's come down here and let's try that insert again. And that was pretty quick. And then we'll come down here and we'll show what we just inserted. Let me do. And this is what's nice is I can think ahead. I can actually go ahead and, if I was fast enough, work on this code cell while the previous one's computing. So this is just doing a select, but it's doing a inner select here. I'm basically saying find the word with the highest value across all files, and then order by the individual files. And what that does for me is it keeps all the information for a file together, but it gives me the file with the highest ranked word first. And I'll show you in this table. So for example, this one had a high doc count and a high total count. So it appeared 27 times, but only in one document. So it got a really high score. Compared to this one, which was 105 times across all documents, but only 6 times in the target document. So this is just some data, and if it's a little confusing, it'll start to come together, I promise, in the next few steps. So let me continue on, because what we're going to do now is I'm going to partition the data frame, and I'm going to show you how you mix and match .NET and Spark SQL code. I've done them separately in the cells, but here I'm using this SQL command to pass SQL in from the .NET side and creating this partition table. What this table is doing is it's ordering the words in each file and giving them a row number, because I'm going to select just the top 10 words. So I need to have them ranked. And here you can see we've got this new row number column. So this is the most important word in this document, and it's going down 1, 2, 3, 4, 5 like that, and it's giving me that ranking. So now that I have the ranking, what I can do is filter and just pull out the top 10 words. That's what I'm going to do in this step. Let's add this on. In this step, I'm going back to Spark SQL. I'm pulling that file that I just created. but I'm filtering to just the top 10. So where row number is less than or equal to 10. So what that's going to do is it's going to give me just the top 10 words, if you will, per file. So we'll go ahead and do that. Okay, so it pulled those out. Now I want to roll everything together, and I'm going to do that in a couple steps. So here's files, row number, word count. So we're starting to get a shape of data. I also want to do reading time. You know, when you read an article, it says it's maybe 5 minutes reading time, 4 minutes reading time. I'm going to compute that, and again, to show you how easy it is, I don't have to translate this to a stored procedure. I created a function that takes a time and turns it into less than a minute, minutes, hours, etc. Then I have another function that divides the word count by words per minute. And I'm assuming 225 words per minute. There's different sources of data for this, but we'll make that assumption. And then I'm registering it as a user-defined function. So now it's available to me to call from my subsequent commands. So we're going to do this step here. And this step has quite a few moving parts, so let me explain that. So for this final one, I'm basically taking it, I'm grouping by file, title, subtitle, word count. So I'm getting back to one row per file instead of multiple rows per word, because I just want to roll it up. I'm aggregating the word column into something called the top 10 words. What that'll do is it'll take those multiple rows and turn them into an array. So it flattens it out into a single row. Then I'm selecting it back and concatenating the array so it turns into a single column. So I've gone from rows to array to a column, and then I order by and show that. So if I run this, what it's going to do is it's going to come back and it's going to show me by file what it thinks the top 10 most important words are per file. And so, for example, this fundamentals of routing has convertible, this one has max length, this one has companions. This is a little tough to see. The show command truncates the data. So we're going to fix that as well, because what's cool about the notebooks is they support HTML views. So you can output HTML and parse it. So what I'm going to do is create a function that takes any data frame, turns it into a list, and just grabs the top 50 off that list, and then builds a table out of it. And it can do that because the data frame has this schema that gives it the fields in the data frame. So that's how I build out the headers. And then I can get the values and just turn them into a string, and that's how I get the details. And I'm basically just building a table. And at the end, I do display HTML and cast that table to a string. So we're going to run this one with that helper method. And this is something that I could put into a library, pull it in, reference it, install it, and use it. So we'll run that. And now what we get is this nice formatted table. So fundamentals of routing. And if we scroll over to the side, we can see transformers, convertible, substring. So we're not getting words like the or to. We're getting, for example, in routing, we're getting routed, conventional, because it's convention-based routing, etc. So this is an example of starting with just a raw data set. And the other thing that, let me see if I can scroll over, because the other thing you're not seeing is, oh, there we go, is reading time. So we've also computed reading time. So basically in real time through the notebook, we've taken in data, we've manipulated it, we applied some formulas, and we're able to reference those from queries that then produced an output data set. And then I could actually save this data set off and go off and do something else. And in the example that I have in GitHub, I then use these columns to automatically categorize and say these documents belong together because of the way that the words are distributed. So that's a pretty powerful capability. The last thing I'll share before I go back to slides and show you some links, and I know we've got some QA in store, is this is True.net, and it allows me to use .NET libraries. So if, for example, I have my favorite tool that I want to use as part of this, I can do #R, which is a reference. I can do quotes, and then I could say NuGet and give it the NuGet package name, and that will load that reference in, and then I can use a using statement. The other really neat thing about notebooks is, if I come back here, is in Visual Studio Code, you have to be on the Insiders build because it's in preview right now. But let me open up Visual Studio Code again. What I can do is create a new blank notebook. And I can do the exact same thing I showed you from right inside Visual Studio Code. Now, if I'm going to use Spark, then I need to have a Spark job running to connect to, but I could use that same container, for example, that I was running before and connect to that here, but I can interactively work with code here. So var x equals 2, and then I can press play, and it's just going to say, yeah, you're right, x equals 2. But if I do x as the last thing in the cell, it'll actually show me the value of x. And then I can add markdown and do steps. So a lot of times, if I'm demoing code samples or if I'm working with data locally, I'll open up a Visual Studio Code notebook and use this notebook locally. But it's nice to know that I can do it in the cloud and have that full power of cloud compute behind what I'm what I'm doing. So that is what I wanted to show you today. I have several links for you that will get you started with Spark, .NET for Spark, and Synapse.NET notebooks. I strongly encourage you to try it out and use the samples that are there. They're great to see exactly what's there. And now I'm going to turn it back over for Q&A.
Hi, Jeremy. Yeah, good morning, everyone. Yeah, we have a few questions regarding your session from the audience. I'm going to read out the questions one by one. So, is that okay? That you have the option to see the published questions, or I'll read it out?
If you could read it out, that'd be great. I'm not on that stream, so.
The first question is, what are the main advantages of .NET Spark over PySpark and Spark-R APIs?
Yeah, the main advantage is if you want to take advantage of existing .NET libraries. If you don't plan to use any .NET libraries, you don't have any code, then using PySpark or any of the existing libraries that's what we would recommend as a team for you to use. In fact, if you're going to use Spark, we would say if you know Scala, if you know Spark SQL, use them. They're native, they're out of the box, they work great. If you don't know those languages and you want to stay with the language that you do know, or if you have existing code that you want to leverage as part of your big data projects, those are both reasons to use .NET for Spark, because then you can write using the language of choice. The performance is par, so we're not necessarily giving you performance benefits, but we're not performing more poorly because we're plugging straight into that Spark core engine. But the caveat is, do you want to use the language and do you want to use the existing libraries? Then it makes sense. Otherwise, those other packages are great.
Okay, hope our attendee got the answer for his question. We'll move into the next question. An attendee is asking, why should we use Azure Synapse workspaces over Azure Databricks workspaces in writing notebooks?
That's a great question. And I would say if you've already got workspaces set up and your notebooks are working fine, that's great. What Synapse strives to do is abstract away the platform underneath so that it's not a concern if it's HD Insight or if it's Databricks. It's just a compute platform that you can run notebooks on, that you can submit jobs. And it's designed to connect multiple types of data sources and give you this control panel. If you're already using Databricks or HD Insight and you're comfortable with that and you've got that environment, then that's a great environment to use. Synapse is going to be something that if you're not already vested in those environments, you don't want to have to configure or set those up. You want a very straightforward front end that abstracts away the underlying. It still gives you the ability to set things like core sizes and clusters, but doesn't require any of the configuration and setup you would ordinarily do. That's when I would go with Azure Synapse.
Okay, thank you. So we'll move on to the next question from Sean. He's asking, can we connect to a Spark pool on Azure Synapse using IntelliJ, Eclipse, PyCharm, or RStudio IDEs?
That's a good question. I don't think you can connect, but I don't know from the top of my head. That's not a scenario I've worked for. I know you can submit, but as far as like interacting, like having a notebook and using that as the engine you connect to, that I would have to check with the team on. Sorry, I don't have a good answer for that.